Welcome students. In the topic of semiconductors, till now you have studied its types, intrinsic and extrinsic semiconductor, their thermal properties, drift and diffusion currents and Einstein equations. Now I will tell you how to solve questions on these topics in competitive exams. There are basically two types of questions, conceptual and numerical. In this video, I will explain the steps and techniques to find the solution of problems by using some examples. And all examples mentioned in this video are already been asked in the competitive exams like GATE, ECE and UGCNET. So please watch the video till end, and if you like it, then subscribe my channel and show your support to motivate me to keep up the good work. Let's start with the conceptual type of questions. To simplify the solving process, you should understand that there are two major types of conceptual questions, and they are formula based and theoretical questions. Formula based questions can be asked in two ways, either directly or indirectly. Direct questions means in which there is no twist, and if you know the formula, its variables and units, then you can answer it within 10 to 15 seconds. While in case of indirect questions, most of the time it is like if one parameter is increasing or decreasing, then how will it affect the another parameter? In case of the theoretical questions, you should know the definition, phenomena, mechanism or for process or principle. Here directly definitions or what is this type of questions can be asked in competitions. Also the questions can be arised with twists and sometimes with false inputs to confuse the students, as in the case of true or false questions. For a better understanding, let's see some examples on semiconductor topics. The first one is drift current in the semiconductors depends upon, options are only the electric field, only the carrier concentration gradient, both the electric field and the carrier concentration, and last is both the electric field and the carrier concentration gradient. So, can you answer this? This is very simple. First of all, this question is formula based and asking directly about the drift current. So, recall the drift current formula, and it is the drift current is equals to A is the cross-sectional area of the semiconductor material multiplied by the charge of the carrier and the concentration of the carrier, and then the mobility of the carrier and electric field. So you can see that drift current is directly proportional to the concentration of the carrier and the electric field, which is our option C. So this is correct. Now the next question is, a p-type silicon sample has higher conductivity compared to an n-type silicon sample having the same dopant concentration. True or false? What do you think? It is true or false? So it is asking about the conductivity of p-type and n-type silicon. So first of all, write the formula. So sigma n, it is the conductivity of n-type material. It is Qn mu n. Mu n is the mobility of electrons, and sigma p is Qp mu p. It is given that the dopant concentration are same, n and p are equal, and charge of the carriers are equal. So we can write that sigma n and sigma p ratio, it is mu n and mu p. As we know that mobility of electrons are greater than the mobility of holes, which clearly shows that the conductivity of n-type material will be greater than the p-type of material. So this answer is false. Now the third question is, what is the mobility? Options: A is of carrier drift, A is of current flow, A is of access to the junction, or A is of movement. So mu is directly proportional to the collision time and inversely proportional to the mass of the carrier, and thus on application of an electric field it becomes easier for the carriers to drift. So the answer is option A is of carrier drift. Now the next fourth question is, what type of material is obtained when an intrinsic semiconductor is doped with pentavalent impurity? So recall what is the pentavalent impurities. So these are which have 5 electrons in the valence shell and only 4 electrons are required to make the covalent bonds with the 4 neighboring silicon atoms. It means that 1 electron is extra, and that semiconductor material where the electrons are extra or the majority carrier, that material will be n-type semiconductor. So answer is option A. Now the fifth question is, why does a gradient occur in a semiconductor? Options are because of current flow, because of diffusion current, because of drift current, or because of difference in the concentrations. So answer is option D. Different level of doping in P and N regions of a semiconductor. Concentrations of carriers varied and the drift from higher to lower concentration, and this is the gradient which results into diffusion current. And remember that diffusion process does not require any energy source like electrical field as in the case of drift current. So answer is D. So students, these are the examples of conceptual MCQs where you have to remember all the formulae, definitions and processes. Now let's see the steps to solve the numerical problems where you have to perform some calculations. Above all, once again learn all the formulae of the topic, and most of the formulae are interrelated, and to learn all these you have to sort out the connecting link between them. And also when you learn these formulae at this initial level of analog electronic circuit, it will automatically become easy to learn higher level formulae of the subject. Now to ace the solving process of a numerical, follow these steps. The step 1 is note down all given entities along with their given units. And second step is convert units of entities into standard or required units if it is not. And the third one, put the values into the formula and then solve it. Now let's see some numerical problems. The first one is, the dependence of the drift velocity of electrons on electric field in a semiconductor is shown below. The semiconductor has a uniform electron concentration and electronic charge. If a bias of 5 volt is applied across a 1 micrometer region of this semiconductor, the resulting current density in this region will be, you need to find out the current density. So first of all, what we have the uniform electron concentration. So this is the concentration, this is the charge of the carriers, and we have the voltage and the length of the material. So from using this you can find out the electric field, and then we need to find out the current density. So these are the given entities, and only one, the length of the semiconductor material is not in the standard unit, so you have to convert this into the 1 microcentimeter. Now the formula of the current density, Jn is Qn mu n E. So students, we have everything. For electric field, use this 5 volt, and 1 micrometer regions mean 10 to power minus 4 microcentimeter region, or you can say 5 into 10 to power 4 volt per centimeter. So using this graph to find out the mobility of the carrier. So the drift velocity is equals to mu n product E, or mu n is the drift velocity upon the electric field. We have the drift velocity 10 to power 7 and electric field is 5 cross 10 to power 5, or you can say 10 to power 2 upon 5. I am not solving it more because it will be convenient to find out the final result. So using this, the Jn, putting all the values, Q is 1.6, 10 to power minus 19, N is 10 to power 16, mu n is 10 to power 2 upon 5, and 5 into 10 to power 4. So this will be solving all these Answer will be 1.6 10 to power 3 ampere per centimeter square. So we need answer in 1000 ampere centimeter square. So it is simple, 1.6 Ka on centimeter square. So this is the answer. Now the next question is, assume the electronic charge this, Kt by Q is 25 millivolt, electron mobility is given, and the concentration gradient of electrons injected into a p-type silicon sample is this. Find the magnitude of the electron diffusion current density. So diffusion current density is J, diffusion is Q, the charge of the carrier, and the diffusion constant and the concentration gradient. We have everything, only this diffusion constant. So using the Einstein equation, so diffusion constant is the product of mobility of the carrier and the Kt by Q. You can put the values and find out. The answer will be, diffusion current density will be 4000 ampere per centimeter square. So students, in this video you have seen how to solve the conceptual and numerical MCQs of the competitive exams on the topic of semiconductors. Do more practice and get more strong holding on the semiconductor topic. I hope you liked the video. So please subscribe the channel for more contents and share it. If you have any queries regarding analog electronic circuit, digital electronics, microprocessors, microcontrollers, embedded systems, VLSI design, you can write me in the comment section or you can mail me. My mail ID is given in the description of the video. Thank you so much and have a nice day.